I've occasionally caught myself chatting away to my dog Bounder. The first sign of madness? Maybe. But I'm not alone, and occasionally she talks back too. But is Bounder, like any dog, really listening to what I'm saying? That's just what Victoria Radcliffe at the University of Sussex wanted to find out.
Speech is quite a complex signal, and it's got a lot of information being transferred at the same time. And one of the things humans do is we divide the information up, and it's processed in different areas of the brain. So we wanted to compare whether dogs also divide up this information and how similar it is to the way that we do it.
As I'm talking to you now, you're not just processing what I'm saying, the words, but also the way I'm saying it, the intonation. And what's more, these types of information are dealt with by different sides or hemispheres of your brain. The left hemisphere processes the what, and the right processes the how. But how would you find out if this is the case for Fido?
We used a behavioural design called head-orienting design, which has been used with lots of different animal species to look at how they process their own species' vocalizations. So the way it works is you have two speakers that are placed either side of the dog, and a sound is played from both speakers at the same time, so that the sound enters both of the dog's ears equally. When sound input goes in through each ear, then it's transferred mainly across to the opposite hemisphere of the brain, and the hemisphere which is more specialized in processing the information works more efficiently. So the sound is heard more clearly from the opposite ear.
In other words, you can work out which side of the dog's brain is handling the information from which way they think the sound is coming from, shown by the way they look. To tease apart words and intonation, some interesting sounds were played to the test subjects. There were phrases the dogs were familiar with.
Come on then!
Then there were phrases with neutral intonation, just containing the words the dog knew.
Come on then.
And also some sounds with intonation, but without any meaning. And it looks like humans, dogs process both the meaning and the intonations of human speech. And they process this information in separate hemispheres, just like we do.
They showed different biases for the different information in speech. So the fact that it had biases in the first place is consistent with the idea that they're perceiving the different information in the signal. So they're not just getting one aspect of the information out. Also, because they showed opposite biases to the verbal information versus the speaker-related information, then it suggests that they're processing these two main aspects of speech differently in different areas of the brain. When they heard the verbal content that was meaningful to them, so the familiar command,
Come on then.
they responded differently to when it was not meaningful to them.
Von om Ken.
So it suggests that the way they're dividing the speech up depends on the relevance of the information to them rather than just the way it's encoded in the signal.
But is this very human way of listening shared only with man's best friend, or can it be found across the animal kingdom?
So we don't know if dogs show these different biases because during domestication it's possible that humans have selected dogs that respond quite well to spoken command. It would have probably been beneficial for them to adapt to be able to understand different information in speech so that they can cooperate and cohabit with humans. So it could be that dogs have converged in the way that they've evolved with humans, or it's possible that other animals would also show this ability if they had enough exposure to speech. So it could be that lots of different mammals have the potential to have these differences, but we've just seen it in dogs because they're exposed to speech quite a lot in their everyday lives. So one of the things we'd like to test is whether these differences are also shared in other species of mammal, and if they were, then it would suggest that these differences that we see in humans in related speech have ancient ancestral origins that are shared across different mammals.
We're also yet to find out whether meaning or tone plays a more important part in how our dogs understand us. But in the meantime, I couldn't resist a little experiment with my dog Bounder, willingly performed by my sister Sarah.
Speak. Speak. Spook. Speak.
Not flawless scientific research maybe, but perhaps one to try at home with your own dog.